In this video, we will show you how to check your data to see if it is normally distributed. So why is it important to know if your data forms a bell-shaped curve, i.e. a normal distribution? Because this is a key assumption in some statistical tests like the t-test, the f-test, the ANOVA. And when you know if your data is normally distributed, it also means that you can apply the empirical rule to calculate probability. Now, there are several ways you can test for normality, but in this video, we'll only show you two ways. The first is by plotting a histogram, and the other is by drawing a qqplot. So the first thing that we do is to bring in the libraries that we'll be using as part of this analysis. And then we bring in our raw data set and give it a name. In this case, we'll name it raw lobster. And then we take a sneak peek at our data set to see what we're dealing with. So the first 5 rows of our data set tells us that this is a data set that is that shows the daily revenue intake at LobsterLand. And then we have to check the data types of each variable as well, because only numerical data can form a normal distribution. You can't do that with categorical data, for example. So dates are out, weekday is also out. But take a look at Maine status and event. Main status and events, like even though there are numbers here, but these numbers don't have mathematical properties, because if you have a look at our dataset description over here, they actually represent something. And so when plotting the histogram, before we can even plot our histogram, we need to drop these two variables. So how do we do that? That is by using the drop function. And we say x is equals 1 at the end because you want to drop columns. So give it another name, in this case, raw lobster 2. And then we isolate all the variables that are either integers or floats. Give that another name. In this case, we'll call them df numerical. And then we write a for loop that essentially helps us plot histograms of all the numerical data that we have, and just makes the whole process much quicker if we use a for loop to do all of this for us. So the first line can be regarded as the setup, and the subsequent lines are the detailed instructions telling Python what to do. The first line over here essentially tells Python, the second line over here basically tells Python to plot each chart on its own. And then the third line tells Python to plot a histogram, specifically a histogram using Seaborn. And the data for that will come from this data frame called df numerical, and the columns in this particular data frame. So when we run the for loop here, then we get all the charts, all the histograms of each and every numerical variable in our data set. So as you can see, low temperature and high temperature, the distribution for these two are slightly skewed towards the left. There's a nice tail here that goes towards the left. And then whereas for day pass, it looks like it is normally distributed. When we eyeball it like that, it looks like it fits a normal distribution. Same thing goes for gold zone revenue. But then if we look at lobster rolls, then that's slightly skewed towards the right. Okay, so as I mentioned before, the day pass looks like one that, it looks like it might be normally distributed, but we're not really sure. So one way to verify that is by drawing what we call a qqplot. And to do this in Python, we first import the libraries these two libraries over here from stats models and from matplotlib. And then we isolate day pass, give it a name. In this case, we'll call it raw day pass. And then we draw the qqplot. So as you can see, there are blue dots over here, and then there's this solid red line. Now, if the data in from day pass, the day pass variable is normally distributed, then all these blue dots over here should follow the red line. And in this case, it does kind of follow the red line, although there's a slight deviation at this point and towards the end. So in general, it's not that bad. And then, but if we look at another variable, lobster rolls, then we can see that this is definitely not normally distributed, because have a look at the tail end of the data over here. Like it's really it really deviates even further from the red line.